Alright, section 6.1 is over properties of exponents. Chapter 6 kind of deals with exponents, exponent properties, exponential functions. We're moving away from linear functions in chapter 6. Most of Algebra 1 is about linear functions, lines, writing equations of lines, graphing lines, solving equations with lines, figuring out where two lines cross, anything like that that deals with lines. That is Algebra 1 in a nutshell. But as we get into chapter 6 here, we're moving away from lines. We're moving to a different type of function. But today we're not going to be working on functions. We're just going to be working with exponents and specifically properties of exponents. Okay, I've got the first three properties listed here. I'm not so concerned that you know the names of these properties. I'm not going to quiz you on which property I'm using. I care that you know how to use those properties correctly. Okay, so I'm going to give you just the algebra notation of each of these three properties. There are 7 total. We'll get to the other 4 here in a minute. But we're going to start with the first 3. Okay, the first one is the product of powers property. The product of powers property says that if we have the same base and we are multiplying the two bases together, okay, a to the m times a to the n. Notice that the bases are the same. What that does for us is it allows us to add the exponents. Okay, so if I had 3 squared times, let me change colors here, 3 cubed. Well, if we wrote this out, that would be 3 times 3. If we expanded that first exponent to 3 times 3, and then the second base becomes times 3 times 3 times 3. Well, how many 3's do I have there? That would be 5, 3 to the 5th power. 2 plus 3 is equal to 5. Okay, so if we have the same base, and the bases are, the bigger parts of your expression, if they are the same and we're multiplying, we simply add the exponents. Notice that our base was 3 for both of them, and the answer, our base, was 3. The base does not change when we're multiplying. It would not become 9 to the 5th power. It is still 3 to the 5th power. All right, let's move on to the next one. The quotient of powers, very similar to the product of powers. Quotient means divide, so if we have a to the m and we are dividing by a to the n, what that means is that we are going to subtract our exponents, a to the m minus n. Okay, so if I had, let me get the right colors here, if I had something like x to the 6th power, and I was going to divide it by x to the, let's go with 2nd power. X to the 6th divided by x to the 2nd. If we wrote this all out, x times x times x times x times x, let's see, that's 5 of them. And then here's a 6th one. And we're going to divide this by x times x. Okay, what happens? X is cancel, x is cancel. I'm left with 4 x's in the numerator, x to the 4th. 6 minus 2 gives me 4. Okay, so that's the quotient of powers property. Again, not so concerned that you know how to use, or I'm sorry, not concerned that you know the names of the properties. I'm concerned that you know how to use them. Okay, the final property for now is power to a power. What power to a power says, if we have a to the m power and we're raising it to the n power, something like x squared to the 4th power. Okay, x squared to the 4th power would mean something like x squared times x squared times x squared, that's a 2, times x squared. Well, if we write it out the expanded version like this, like I just underlined, it becomes a lot like the product of powers property. If I add up all these exponents, 2 plus 2 plus 2 plus 2, that would give me x to the 8th power. The quicker way, how are 2, 4, and 8 related? Well, 2 times 4 is 8. So what the power to a power property says is if we have two exponents right next to each other, like we've got here, we can simplify it by multiplying them. A to the mn power. Okay, so for one more example here, let me do this one in yellow. If I had, let's say I had 3 to the 2nd power, let me change that. Let's not use 2nd power again. Let's use 3 to the 5th power, 3 to the 5th, and we'll raise that to the 7th power. If the two exponents are right next to each other like these two, all we can do, or all we need to do, is multiply our exponents. 5 times 7 would be 35, so 3 to the 35th power. I have no idea what 3 to the 35th power is. It's a large number, but that's what our answer would be, 3 to the 35th power. Let's try a few more examples here. Simplify or evaluate. Simplify involves variables. Evaluating means numbers. If you ever get a direction that says evaluate, so if you had something like 2 to the 4th power, actually go ahead and do 2 times 2 times 2 times 2, which is 16. So if it says evaluate 2 to the 4th power, 16 is the number they're looking for. All right, kind of an aside there. Let's get into the examples here. We're going to start with 3 to the 2nd times 3 to the 6th power. This is product of powers property. Again, I'm not real good with the names. I'm concerned that you know how to use the exponent properties correctly. Okay, so we have the same base and we are multiplying, which means we need to add these two exponents together. The base doesn't change, it's still a 3. 2 plus 6, I'll write this out, 2 plus 6, it's going to give me 3 to the 8th power. If you type in 3 to the 8th power in your calculator, you should come up with an answer of 6,561. Let's try another one. Number 2, this one's going to have variables in it. Let's go w to the 12th, and we'll raise that to the 7th power. This one, if we flip back, this one is power to a power. Okay, we got two exponents right next to each other. That's a 12, by the way. Let me see if I can't make that a little better. 1, 2. There, that's better. W to the 12th to the 7th power. If we have two exponents right next to each other, like we've got right here, all we're going to do is multiply the two exponents together. 12 times 7 is 84. We don't know what W is, so this is more of an example of simplifying. We don't know what W is, so we leave it as W to the 84th power. Let's try another one here. Number 3, x to the 8th over x to the 3rd. X to the 8th over x to the 3rd. This one is the quotient of powers property. We got the same base, x and x, and we're dividing these two bases. So what we're going to do with these two exponents, 8 and 3, is subtract. And it is always top minus bottom. When we're subtracting, it's always top minus bottom. So 8 minus 3 gives us 5. So x to the 5th power is our answer. Let's try one more here. Number 4. D to the negative 3rd power in parentheses. We're going to raise that to the 5th power. Again, we have two exponents right next to each other. So all we're going to do is multiply the two exponents. Negative 3 times 5 gives us negative 15. Now there's something special with an exponent that's negative. That's another property. We'll get to those in just a second. The next two exponent properties I want to discuss might be the easiest and the hardest of all the properties. We'll start with the easiest one, the zero exponent property. Zero exponent property says if we take a, whatever number you want to choose, and raise it to the 0 power. If you pick a number, type it in your calculator, raise it to the 0 power, you will get 1. Okay? You will get 1 every time. There is one number that won't work though. There is one number that a cannot be, and that number is 0. So any other number that you pick, raise it to the 0 power, you will get 1. I promise. The one catch here is that the number that you choose, whether it's positive or negative, especially if it's negative, I would put it in parentheses. So let's just say the number I pick is negative 8. If I type in negative 8 to the 0 power with parentheses, the calculator will give me 1, and that is correct. But if I type in, I'll do this one here in blue, if I just type in negative 8 to the 0 power in my calculator, it will give me negative 1. And the calculator is not wrong. The calculator is doing the order of operations. It's doing the exponent first and then multiplying it by negative 1. Okay, so be very careful. If the number you need to raise to a power is negative, I would always put it in parentheses in your calculator. Okay, no matter what number you want to choose, if you're raising it to the 0 power, the answer is 1. If the number you're choosing is negative, make sure you put it in parentheses in the calculator. Cannot stress that enough. That's the easy one. The harder one is the negative exponent property. Okay, the negative exponent property, we want to turn, the reason we have this, let's just put it this way, the reason we have the negative exponent property is because we want to turn all negative exponents we want to turn them into positives. We want to turn negative exponents into positives. We know we don't want to write our final answer with negative exponents. It just doesn't look good. It doesn't fit right. Okay, so what the negative exponent property says, if we have a to the negative m, so our exponent is going to be negative. The way we make it positive is that we move it, so this would be like a to the negative m over 1. The way we make it positive is the base and the exponent flip which side of the fraction it's on. If it's in the numerator, then it goes down to the denominator. The base does not change signs. It's not like we're flipping the sign of the base. The base stays the same. The only thing that changes is the exponent. It goes from negative to positive. If there's nothing left in this numerator after you've moved it, it becomes a 1. Okay? Similarly, if we had a negative exponent in the denominator, a to the negative m, 1 over a to the negative m, I'm sorry. Again, it's in the bottom, so move it up to the top, a to the positive m. If there's nothing left in the bottom, then it would be over 1. But if it's over 1, yeah, we really don't need to write it. So it would just be a to the m. Why does this work? Well, let me show you. You can do this example with any number you choose. I'm going to choose something fairly easy. I'm going to choose 2. So if I go 2 to the third, 2 squared, 2 to the first, 2 to the 0, 2 to the negative 1, 2 to the negative 2, and then I'll do one more here. 2 to the negative 3. That's a negative. Okay, I'm going to start up here with 2 to the third power. 2 to the third power is 8. You can type that in your calculator to check. 2 to the second power is 4. 2 to the first power is 2. Now, if I go down a line, that would be like dividing by 2. If I go up a line, that would be like multiplying by 2. Okay? So if we keep going with the down, 4 divided by 2 gives us 2. Well, let me see. Let me fill in some equal signs here. That was supposed to be in red. Equals, equals, equals. We'll leave the 2 to the negative third for a minute. If I go down another line, keep dividing by 2, 2 divided by 2 is 1. Well, that should make sense. The zero exponent property says any number to the 0 power is 1. You can pick any number for your base here. Once you get down to that base to the 0 power, you're always going to get back to 1. Okay, so now let's keep going. What if we divide 1 by 2? What do I get? Well, I get 1 over 2, 1/2. Okay, what's half of a half? If we divide by 2 again, that would be 1 over 4. Okay, let's do it one more time. Whoops. Let me erase that, put that back in red. Bring our arrow one more time, divide by 2. Half of 1/4. If I have a fourth of a pizza and I cut it in half, how much of the original pizza do I have? That would be 1/8. Okay, well, how could we rewrite 1/2, 1/4, and 1/8 with positive exponents? 2 would be like 2 to the first. 4 is the same as 2 squared, 2 to the second power, and 1/8 is the same as 1 over 2 to the third power. So I started with 2 to the negative third. Once I move this down to the bottom of the fraction, it becomes 1 over 2 to the third. And then we can end up going back this way to the left and get 1 over 8. That might be a little confusing, I know. It makes sense for some people. It makes sense for not some people. That's okay. If it doesn't make sense to you, that's all right. That's not the focus of the lesson. That example. What I really want you to focus on is this. Okay, if you have a negative exponent, we want to make it positive, and we do that by moving it to the opposite side of the fraction. All right, let's try a couple of examples here. Directions say evaluate or simplify. Write your answer using only positive exponents. So we're probably going to need to use that negative exponent property to simplify some things here. So let's start with number 1. We're going to start with a fairly easy one. 6.7 to the 0 power. If we have a 0 power or the exponent of 0, it's real easy. Go back to the 0 exponent property. Let me scroll back up there. Any number to the 0 power. The answer is always 1. So your answer there for number 1 is 1. Pretty easy. Number 2, we're going to go with -2 to the -4th power. Okay, so this one will be an evaluate type of problem because we've got numbers. 2, -2 to the -4th power. We want to get rid of this -4th power first. Okay, so it was in the numerator. Since you don't see a fraction, it'd be like over 1. Get rid of that here. So this now becomes the denominator, -2 to the 4th power, and I'm keeping -2 in parentheses. Makes a huge difference. Nothing left in the numerator, so that becomes a 1. -2 to the 4th power, that's like -2 times -2 times -2 times -2. If I have 4 negatives, that actually becomes a positive. 1 stays in the numerator, 2 to the 4th power, -2 to the 4th power is 16. Okay, so 1 over 16 is your answer, for number 2. Number 3, let's go with x to the 9th times x to the -9th. That's a -9. Let's try that again. -9. There we go. Okay, so we've got a couple different options here. What I see right away is I see a base that are the same. We're multiplying, so all we need to do is add the exponents together. 9 plus -9, well, that's pretty easy. That's 0. We can go farther with this one. Any number, any variable, anything to the 0 power is 1. We're going to assume that x is not 0. Number 4. Let's try another one here. How about 10 to the 4th times 10 to the -6th power? Again, I see same base, we're multiplying, so we add the two exponents together. The base does not change, it's still 10. 4 plus -6, same thing as 4 minus 6, that would be -2. Now what I see a negative exponent. So let's make it positive. This is the numerator, 10 to the -2nd is in the numerator, so that's 10 to the -2nd over 1. So we're going to make it positive, make this exponent positive by taking it down to the denominator along with its base. So 10 to the +2nd, we don't have anything left up top, so then it's going to be a 1. 10 to the 2nd power, we know that. 10 times 10, that would be 100. So our answer for number 4, 1 over 100. Whoops. Still learning the scroll. Alright, number 5. Last one for this set. Number 5, 3 to the -2nd power, x to the -5th power, all over y to the 0. Alright, first thing I see here, I see y to the 0 power. Any number to the 0 power, that's like 1. Okay, so really this is 3 to the -2nd over x to the -5th. We don't need to worry about y to the 0 because it's 1. Okay, we're going to make the assumption that the value of y is not 0. So we need to work on both the 3 to the -2nd and x to the -5th. Okay, they both have negative exponents, so they need to go down to the bottom of our fraction. Okay, so on the bottom of our fraction now it's going to be 3 to the +2nd, x to the +5th. We don't have anything left up top, so then it becomes a 1. We can go farther though. 3 to the 2nd power, 3 times 3 is 9. We don't know what x is, so we have to leave that as x to the 5th. 1 stays on top. So 1 over 9x to the 5th power is our answer. Alright, the last two exponent properties. Product to a power and fraction to a power. Product to a power looks exactly like it sounds. We have a product, a times b. We're raising it to a power. A times b to the m power. This is the one chance that you get to actually distribute an exponent. Okay, so if you had a plus b to the m power, you don't get to do that. You don't get to distribute an exponent like that. The only time you get to distribute an exponent is if it's multiplying two things and then raising it to a power. Okay, so this would be like a to the m, b to the m. Okay, so for example, if I had something like 3x to the 3rd power, this is a distributive part, or a distributive similarity, I guess you could call it, where both parts of that product, 3 to the 3rd, x to the 3rd, where both parts of the power, or both parts of the product, receive that power. Okay, so 3 to the 3rd, we can go farther, that'd be 27, and then x to the 3rd. If there were more than two parts to the product, let's say it was 4xy squared, again, everything gets the power of 2. Okay, so it'd be 4 squared, x squared, y squared, which then would become 16x squared, y squared. Kind of getting off topic, kind of, but just giving a couple of examples of how product to a power works. The last exponent property is fraction to a power, and that one sounds even more or looks even more like it sounds. We have a fraction, raise it to a power. Again, just like product to a power, this is your one chance to distribute an exponent, actually your second chance to distribute an exponent, but these are the only two times you get to do that. Okay, so this will be a to the m over b to the m. For example, if you had something, we'll use numbers this time, 2/3 to the third power. Okay, we can distribute this exponent of 3 to become 2 to the third over 3 to the third, which 2 to the third would be 8, 3 to the third would be 27. There's no common factors there, so 8 over 27 would be your answer. If you had variables, let's say we had x to the, we'll just say x over, we'll make a number there, x over 4, and we'll raise that to the fourth power. Again, you can distribute that outer exponent, so it becomes x to the fourth over 4 to the fourth. X to the fourth, we don't know what that is because we don't know what x is, so we leave it as x to the fourth. 4 to the fourth, though, you can actually do that one. I believe that would be 256. All right, let's do 3 examples, and then we'll call it good for the video. Okay, so evaluate or simplify. Write your answer using only positive exponents. Number 1, let's go with 10y to the negative third power. I'm actually going to show you 2 different ways to do this one. First way, we distribute this exponent. Okay, so this becomes 10 to the negative third, y to the negative third, because we do have that power to a, or product to a power property. And now we need to make these exponents positive. This is not positive 3. That's a bad negative sign. Negative 3. Okay. Both of them have negative exponents, which means both of them are going to head down to the other side of the fraction. 10 to the third, y to the third. Nothing left on top, so it's going to be 1. So then this becomes 10 to the third. We know what that is. Or what you can do, you can type that in your calculator, get 1,000, and then y to the third on the bottom. Let's try that 3 again. 3. Okay, so 1 over 1,000 y to the third. The other way you could have done that, go ahead and make that negative 3 positive already. The base on negative 3 is 10y, so this becomes 1 over 10y to the positive third. Again, the base doesn't change when you switch which side of the fraction it's on. The only thing that changes is the exponent. It goes from negative to positive, and then we distribute like normal. 1 over 10 to the third, y to the third, and then it's just the same problem. Just a couple different ways to approach that problem. Okay? Number 2, second to last one. We have a fraction, negative 4 over n, and we're going to raise that to the fifth power. Now, when you got a negative out in front of the fraction, what I would do is I would just decide where you want to put that negative sign. I would always put the negative sign on the top, the numerator of your fraction, if at all possible. So really this becomes negative 4 over n. I would distribute this exponent on the fraction right away. So this becomes negative 4, and again I'm putting a negative number in parentheses with an exponent, just makes it a lot simpler, and then n to the fifth on the bottom. Negative 4 to the fifth, negative 4 times negative 4 times negative 4 times negative 4 times negative 4. I think that was 5 negative 4s. When you type this in your calculator, you do get negative 1024. N to the fifth, we don't know what n is, so it's got to stay n to the fifth. If you want to put the negative sign back out in front of the fraction, you can, but leaving it in the top, that's fine with me. Last one, number 3. Leave this down here so you can see it a little better. We have another fraction, 1 over 2k squared. We're going to raise that to the fifth power. Okay, what I see a fraction to a power right away. So this is going to become 1 to the fifth over 2k squared to the fifth. Now, 1 to the fifth, that's easy. That's 1. 1 times 1 times 1 times 1 times 1. Okay, 2k squared to the fifth. We have a product here. We've got 2 times k squared, and we're raising that to the fifth power. So we're going to distribute that outer exponent of 5 to both parts of that denominator. So this becomes 2 to the fifth times k squared to the fifth. Okay, let me slide this up. So we still have a 1 on the top. 2 to the fifth power, if you type that in your calculator, 2 times 2 times 2 times 2 times 2, that is 32. What we have here in this k squared to the fifth power, let me change colors here, k squared to the fifth, I see 2 exponents right next to each other. And that would be way back one of those first properties, power to a power. If you got two exponents right next to each other, you need to multiply them. So that becomes 32k to the 10th power. 2 times 5 gives you 10. A little more complicated of a problem. We're using a couple properties there. In the same problem, we used fraction to a power, we used power to a power, and we used, product to a power, and then power to a power as well. So 3 different properties in the same problem. Very, very common, very likely to happen throughout your assignment. If you have questions, jot them down, ask me in class. Hopefully I can get them answered right away.